starting at the beginning of the review guide here, here's your video. I'll try to go through the entire review guide in a couple videos probably. But starting out number one up here, okay, number one, you're going to divide the polynomials. So you can do it with either long division or synthetic division. Synthetic division is probably the easier here. So remember, you take the second part over here, you set it equal to 0 to solve for x. You get x equals -2. That's what's going in your box. Okay, so then you use the coefficients out in front of the variables. Excuse me. And you use that for your synthetic division. First one drops down, and then you take it and you multiply by the number in the box. Okay, so it's -2, and then you add those going down. So it's 3 times a -2 again. That gives me a -6. We add those, so it's a -13. And then times the -2 again, so it's 26. Gives me a remainder of 28. All right, and what we're looking for here is the polynomial we get after we divide out that x plus 2. So I need to turn these numbers down here back into a polynomial with that as my remainder. Okay. So this would be an x squared plus 3x minus 13 plus 28. That goes over my divisor there, so x plus 2. So that is your answer, okay? You're not going to get like a numerical answer here, you're going to get a polynomial, okay, because that's polynomial division. Number 2 is the same thing, however, you can do synthetic division, okay? So since there is a 2 here, we have to divide everything by 2, okay, which that could create some pretty terrible fractions. All right, so I am going to do long division just so we can kind of review long division. All right, so the 2x plus 7 goes on the outside of the box, and then I have 2x cubed plus 17x squared, 23x minus 42. All right. Now remember, there are some times where you might not have that x squared, so you might have to add placeholders. Okay, sometimes you might have to. Here we don't. All right, so I'm just kind of making you aware of that. All right, so when we do long division, we try to figure out how we can get this term to look like that one. What are you going to multiply to get those first two terms to look the same? We already have the 2. That's good. We need an x squared because 2x times x squared gets me to that 2x cubed. All right, so we want to do an x squared. That's the term that goes up top. And then I take the x squared and I multiply it through there. That gives me the stuff below. All right. So that would give me a 2x cubed plus 7x squared. And remember, once we put those down there now, we have to subtract them. Okay, so you change your sign once you put them down there. So that way those will cancel. That's the goal. All right, so we get a 10x squared, drop down to 23x, and then we do the same thing. So what can I do to this 2x to make it be a 10x squared? That would be taken times 5x. So that gets me to 10x squared. 5 times 7 is 35. And then change your signs. So 10s will cancel. I'm left with it would be a 12, a -12x minus 42. Okay, I'm kind of running out of room here. So I dropped that 42 down. So how can I make the 2 into a -12? That'd be a -6. All right, so then I'll have -12x minus 42. I'm just rewriting that stuff on the bottom. Take that -6 through here. That gives me a -12x minus 42. And look what's going to happen. So I change my signs, and everything canceled out. So I get a 0 down there. So that's good. That's no remainder. So that means this is my solution. The x squared plus 5x minus 6. There's no remainder, so you don't have to write anything. Okay? Kind of nice. All right, next round. So subtraction. All you got to do is distribute that negative through there and then combine like terms. All right, so I'm going to have 9z squared minus 4z squared. So that's 5z squared. Positive 3z, positive 8z, so that's 11z. -7, -9, so that's -16. That's your solution. okay? For 4, multiply. This is kind of big. So what you got to do is you take these first two and you multiply them out first, which is going to give me 12x minus, or 12x squared minus 6x plus 32x minus 16. Combine like terms. 12x squared plus 26x minus 16. I think I might need a calculator for this one. All right, so then we take the next one, multiply it through there. All right, so 5x times 12x squared, that gives me 60x cubed. And then 5x times 26, so that would give me 130? No, let me double check. So 26 times 5, 130, yep. So plus 130 x squared minus 5 times 16, that would give me an 80x. And now I do the 7 times everything. So 7 times 12 is 84 x squared. And it works good to line it up once you get bigger polynomials like this. You line up the matching terms. Okay, 7 times 26x, that would be 140, 182. So plus 182x, and then 7 times the 16 would be 112. Check that one. 7 times 16, 112. Minus 112. Okay, then add like terms. So 60x cubed plus 214x squared plus 174x minus 112. All right, that would be the answer. All right, so when you're doing these bigger polynomials like this, it's just kind of, oh, I made a mistake here. That should be an 80x up there. This should be an 80x, not an 8x. 80x. And then that changes the 174 to a 102. Okay, quick fix. The big thing here is try to stay organized when you're doing these larger polynomials, because you can kind of lose your place in those. All right, number 5. Best thing to do here, simplify on the inside first. Simplify on the inside first. So I can rewrite this, have x squared, y to the negative 3. So that negative 1 goes into both of those there. X to the negative 1, y to the negative 4. All right? So you can continue to simplify on the inside here, or you can take the 5 through everything. I'm just going to kind of simplify everything on the inside. So when you're thinking of these variables here, when you take that one and that into consideration, look where the larger of the two exponents are. So that would be up here. That's where you want to move them to. All right? So then the y, the larger one's on top up there also. Okay? So when you move them up, variables become positive, or the exponents, so you're going to have an x cubed. And if I add 4 to that, you just have a y to the 5th power. So that's pretty easy there. X to the 15, y to the 5th. So number 6 is kind of similar with properties of exponents. You give the 6 to everything. So negative 2 to the 6th power, that becomes positive. All right. That would be a positive, be 2 times 2 is 4, 8, 16, 32, 64 maybe? 2 times 2 is 4, 8, 16, 32, yep, 64. So we have 64, a to the 30, b to the 18th. And then this is a negative 3, so that bounces down to the bottom in cubes. So that would be a negative 64, because negative 4 cubed is a negative 64. A to the 15th, b to the 18th. All right? And then you can simplify from there. So the 64s will cancel. We're going to have a negative out front. 15 of the a's will cancel. And all of the b's will cancel. So it'll be negative a to the 15th power. All right? Down at the bottom. Solve. So these take a little bit more effort here. Solve these equations. So first thing you want to do to solve these is set it equal to 0. In order order for you to do that, you have to put everything on the same side, and it does work much better to organize these when you put them all on the same side. To organize them in decreasing order of the exponents. All right, so then you look for a greatest common factor. What can you take out? All right, we could take out a 3 from everything and also an x. So then that's what we're going to have. And then we'll have x to the 4th minus 6, x squared plus 5. Okay, there's two ways to do this. You can do this with u substitution, where you say u equals x squared, because that's the middle term here. Okay? Or you can just kind of factor it like normal. I like to do that better. I'll do it both ways. Okay, I'll probably save the u substitution, or won't use u substitution again. So for the u substitution, let's just look at this spot right here. If I have x squared as my u, then I can say that u squared is x to the 4th, right? So if I do squared, that would square that one, so it would be 4th power. Okay, so I have u squared minus 6u plus 5, and then I can factor that like normal. So it would be u minus 5, u minus 1 equals 0. Then I have to change the u's back into x squareds. So it would be x squared minus 5 and x squared minus 1 equals 0. Solve them. Okay, well this one I can split up. X minus 1, x plus 1, because that's difference of squares. This one here, I can't use any patterns, so I have to just set it equal to 0. And then solve for x. So add 5, you get x squared equals 5, square root both sides. So x equals plus or minus square root of 5. Oops, this should be a plus 1 over here. All right, so then I have for my solutions, this right here, back up top, gives me a 0 as a solution. So I have x equals 0, and then I have x equals plus or minus square root of 5, x equals 1, and negative 1. So another thing to remember, taking into consideration the degree of the polynomial, how many solutions are we going to have? Okay, it's a 5th power polynomial, so that means we will have 5 solutions. So 1, 2, 3, 4, 5. Did it right. Okay, those are all the solutions. All right, so I'm going to erase the u substitution part just so you can kind of see that we're going to get the same thing. All right, so if I just look at this polynomial back up here again, okay, I'm going to say, what can I do in 2 parentheses to get me to an x to the 4th out front? Well, I know that I'm going to have to use an x squared here and an x squared here. And then the rest of it is just like normal factoring. So how can I get that 5 and negative 6? So two numbers to multiply to give you a positive 5 and add to give you a negative 6. Well, that's that negative 5 and negative 1. So then, just like we did before, you're on to this step down here. Okay, so you will get the same answer without using u substitution. It's a little bit quicker if you don't use u substitution, but either way would be fine. Okay, on to number 8. How do you simplify a rational expression like this? Okay, think of the only thing that you can do is factor. So you have to factor the stuff on the top. All right, so this stuff right here, if I factor that, 2 numbers that multiply to give me a negative 6 and add to give me a positive 1. It's 3 and 2. Okay, so t plus 3, t minus 2. That's what you get. And then how are you going to simplify this? You should see that the t minus 2's will cancel. And t plus 3 is your final solution. All right? Now remember, if you have something like this that cancels, you could also have another problem that says what type of discontinuity. This would be a hole in the graph. Okay? And it's removable discontinuity. Okay, that's what that is called when one of the factors cancels out. It's a hole in the graph, it's a removable discontinuity. Okay? Something you might want to keep in mind. On to the second side. Okay, factor completely, lots of factoring. All right, so what can you do to the first one here? What can we take out? That's the question. Okay, we can take out a 2. If we take out a 2, I'm left with z to the 4th minus, what is that, 625? Okay, And then we have difference of squares going on. So 25 times 25 is 625. You could get that by trial and error if you didn't know. So z squared minus 25, z squared plus 25. Then we have difference of squares again right there. Oops, too far. Okay, difference of squares again right there. So we got to split that up. All right, so 2 stays out front. We got z minus 5, z plus 5, and then the z squared plus 25. That cannot be factored, so that is your final answer. Okay. When it's looking for factors, that's all you got to do. You don't have to solve anything. You don't have to do x equals something because it's just factoring. All right, so just factor it. 10, factor completely. This is the other one I was thinking about when we had use substitution. I'm going to do it without use substitution. What do we need to put in the front of the parentheses to get the d to the 4th? Okay, d squared and d squared. When I multiply those, that gives me a d to the 4th. Okay. So then how do we get the 10 in the back and the 7 in the middle? Two numbers that multiply to give us 10 and add to give us 7. It's 5 and 2. Okay? Then look at it, see if you can solve, or not solve, factor anymore, and it doesn't look like it because 2 and 5 are not perfect squares. That's it. Okay? 11, 12, 13. Okay, let's look at 11. Factor completely. So one thing you can do if you have 4 terms, you got 1, 2, 3, 4 terms. Okay, you want to see if you can factor by grouping. That means cut it in half. Can I factor something out of the left and factor something out of the right? You can. I can take an x cubed out over here, and I get x squared minus 25. Okay? And then I can take what can I take out of the right-hand side? A 64 over here. Okay? And you have to put a plus there because I'm taking out a positive 64. And I'm left with x squared minus 25 again. All right? So your goal with factor by grouping is to get the same thing in those parentheses right there, which we have. So now you take the things out front, put them in their own parentheses, and then you take the polynomial there and there, you put them together as 1, because that is my greatest common factor. All right, and then there's actually 2 patterns that we can use here. So this one here is sum of cubes. This one here, difference of squares. All right, so if you can look up the sum of cubes, you have to figure out what our a and our b are going to be, and I'll write it like I used to. Okay, so a, take the cube root, you get an x. B, take the cube root, you get a 4. Okay, and then it's SOAP from there. So same, opposite, always positive, and you kind of have to remember how we filled in the blanks. So front 1 squared goes there, back 1 squared goes there, and 2 of them multiplied together goes there. So that's your difference of square, or difference of cubes, or sum of cubes. Either way, it's kind of the same way. Difference of squares breaks down into x minus 5, x plus 5. So that's kind of a big answer. You can run into that with factoring, though. All right, 12. We're going to try to do factor by grouping again. Cut it in half. Take out an x squared. X minus 6. All right? And then we look over here off the right-hand side. We can take out a 4, positive 4. X minus 6 again. So that works out because we have the same thing in the parentheses. We got x minus 6 twice. So that is your greatest common factor. X minus 6. And then we have x squared plus 4. So then this says find all the zeros. So we actually have to continue and solve this one because we want to find the zero. So I factored it completely, all right, because we can't break that x squared plus 4 up because there is no pattern for sum of squares, just difference of squares. And then we have to solve it here. So this one gives me a 6 as an answer. This one I actually have to set equal to 0. X squared plus 4 equals 0, and then solve that. So subtract the 4. I get x squared equals negative 4, then you square root both sides. I get x equals, so a negative underneath a square root becomes an I, And then the square root of 4 is 2. So it would be plus or minus 2i for that one. So I have plus or minus 2i there. X equals 6. 3 answers. Cubic, what did I begin with? All right, let's finish up this page. So 13, find all the factors and the zeros. So this one's kind of big. There is no way to factor 5 terms. Okay, we've never learned a way to factor 5 terms. The only thing that we have learned how to do is rational zeros theorem. All right, so that's where you take the number in the back, factors of the number in the back over factors of the number in the front. So it's factors of 4 over factors of 1. So it doesn't really change it, so just think of factors of 4. So both positive and negative factors, we have a 1, a 2, and a 4. Okay? So then you start plugging them in to see what you get. All right? Oops. Start plugging them in to see which one is going to give you a 0. And once you hit one of those that gives you a 0, that's what you have to divide out. Okay? When you start plugging them in your calculator, that's not going to work, that's not going to work, that won't work, negative 2 is the one that gives us a 0. Okay? So then we can do a negative 2 in our box, and then use synthetic division to break it down. Okay, so first one drops down, multiply, multiply, and we got a 0, so that works out good. All right, now from here, this would be like an x to the third because we broke it down. We took out one of the x's. So we don't really, there is no way you can factor this again yet. So what you're going to have to do is this step again. Plug in factors of that back number, which is a negative 2. Okay? And you are going to find, you're going to find that the negative 2 is the one that works again. All right, so I'm just going to do a negative 2 with synthetic division again and break it down even further. Okay? And then we get that. All right, so now we can rewrite this as x plus 2 squared because I used 2 of them. And then I can rewrite this as x minus 2, x squared minus 2x, minus 1. And now this right here, it doesn't factor. Okay, so when you have a quadratic that doesn't factor, you're going to have to use the quadratic formula, which is this. All right, so we're plugging stuff into there, where a, b, and c are the numbers in front of the coefficients. So it's going to be opposite of b, which will give me a positive 2, plus or minus square root of b squared, which is 4, minus 4ac, plus minus 4 times a negative 1, so that gives me plus 4 in here all over 2a, which would be a 2. So this becomes square root of 8, which is 2 square root 2 over 2. So then we need to simplify because there's a 2 here, here, and here. So you get 1 plus or minus square root of 2. That's what you get for your 0 there. And then we can't forget about this one. That gives us a negative 2 as a 0. So, and technically the negative 2 is twice, so that's where the 4 answers come from. Okay? So that is how we do that one. I'm going to get rid of the quadratic formula. I need to do the other one. So let's try the second one here. Okay? So we have 4 terms again. That's good. 4 terms usually may mean factored by grouping. So cut it in half. Take out an x cubed in the front. X plus 5. Take out a 4x squared. Oops, sorry, 4x, not a 4x squared. We don't have enough x's to do that. So take out a 4x in the back, and we get an x plus 5. So that's nice. It works out with grouping. We have an x plus 5 in both of our parentheses. Okay, so that's our greatest common factor. And then we have x cubed plus 4x. All right, so we're going to have to continue breaking this one down because there's an x in both of them. Okay, so let's take an x out of there. So I'm going to put that way out front just to kind of keep it there. So x plus 5, and I took an x out of this one, so I get an x squared plus 4. So that is completely factored right there. Now we just need to solve. So we set it equal to 0 to solve, and then this gives us a 0, this gives us a negative 5, and this is just like the one up above. We get a plus or minus 2i. Plus or minus 2i. So there's 2, 3, 4 solutions. All right, so 15, 16. Find the value of k so the remainder is 7. So you want to use synthetic division with this type of problem. All right, and this might be like a bonus type problem. I wouldn't give you this on the test. So I'm going to put a negative 2 in my box, and then I can use my coefficients. So here, just like I said earlier, you don't have all the x's that you need. We got x cubed, no x squareds. We have k x's, and then a negative 9 as the last number. Okay, so you're going to have to kind of work from both directions on this one. All right, so we know that the remainder is 7. So that's the information we can fill out right now. So I'm going to kind of work from left to right until I get to that k. So the 1 comes down, the multiply, so it's negative 2, 4. All right, and now I'm going to have to work from the other direction. Here, we know that we add with the negative 9. What can we add with the negative 9 to get a positive 7? That would be a 16. Okay, now to get from here to here, we know that we're multiplying by a negative 2. Okay, so what times a negative 2? What times a negative 2 gets me to a 16? Negative 8. Right, so negative 8 times a negative 2 gets me to a positive 16. Now we can figure out what k is, because what plus 4 gets me to a negative 8? That would be a negative 12. Okay, negative 12 plus 4 is negative 8. That's what k is. All right, so see how that works? You kind of work from both directions to get to that k. All right, so 16, use synthetic and direct substitution to find f of 3. So f of 3, that just means we're going to plug in 3 for all the x's that you see. Okay, so that would look like this. F of 3 equals 3 squared minus 9 times 3 plus 5. So let's kind of simplify this a little bit. 3 squared is 9. 9 times 3 is 27. Plus 5, and then we just kind of simply add the numbers. So 9 minus 27, that's a negative 18. Plus 5, negative 13. F of 3 is negative 13. Okay? Let's do one more page on this video. All right, so 17, you're given a graph of a function and you have to try to figure out this information. All right, so a degree is even or odd. So remember, even functions, they go the same direction, either up or down. Odd direction or odd functions are kind of like a line. They go opposite directions. One's going up, one's going down. So you can kind of use that information to look at this one and figure out, well, I got, this is going positive infinity here, this is going negative infinity here. So that means it's going to be an odd function. Okay? Leading coefficient. Where is the graph going as I look from left to right? As I look this way, where's the graph going? It's going up. What types of things are associated with up? That would be positive things. Okay? How many relative maximum? So remember, maximum are top points. Okay, so you have 2 of them. Relative minimum, low points. You got 2 of them. Least degree of the polynomial. So if you don't remember this one, there was kind of a little trick to determining this. You can look at all the roots if you want to, but that's kind of a headache. Just look at the number of maximums and minimums and add 1. So we have 1, 2, 3, 4 potential maximums and minimums. So that means we must have at least a 5th degree. It's n plus 1, the number of terms plus 1. Real zeros. Count where it crosses the axis. How many times? We got 1, 2, 3. Okay, there's 3 zeros, and technically there's 4, because when you have a bounce point like this, that's a double 0, because that counts as 2. So there's technically 4 zeros. All right, known factors based on the real zeros. So we can have x minus 2, actually x plus 2, sorry, because this is, I'll get rid of this stuff over here. Okay, because we got to look and see where it hits the graph. So that's a negative 2 there. We got a 0 and a 1. So I have x minus 2. I just put them in parentheses with factors. All right, so there's always x minus something. So x plus 2. And then I have x minus 0, which I'll just write it like that for now. And then the 1 here, so that's going to be x minus 1 squared because it's a double. And technically, we don't need to write the x minus 0, so it should actually look like this. And then that would be your polynomial after you multiply all that stuff out. Okay, but we wouldn't have that imaginary 0, which is okay. Domain and range, you look from left to right and top to bottom. So is it ever going to stop going in any directions? No. Domain is all real. Oops, range is all real as well. All right, so domain and range are both all real numbers. All right, going down. See if we can get through this page. Write a polynomial function of least degree with a leading coefficient of 1 given the following zeros. So we have an imaginary 0 in there. There was a complex conjugates theorem before that said every time you have an imaginary number, you're going to have both the positive and the negative of that number. So you would also need that. And then you turn all of these into factors, and you multiply it out. All right, so then you just multiply that out, and you can get to your answer. Okay, so you start with these, and when you multiply them out, so I'll do it with the i's here quick. So it'll be x squared plus 3xi minus 3xi, minus 9i squared. So you can see that these 3xi's in the middle will cancel. And then you have x squared minus 9i squared, which you know that I squared turns into a negative 1. So really, this is x plus 9. X squared plus 9. Okay? And then you just take it times that last polynomial. So it would be x cubed plus, it would be 4x squared. I'm kind of multiplying it while I'm, or organizing it while I'm multiplying it. Plus 36. That would be the polynomial. Oops. Okay, so that's your solution. Inverses, there are inverses on the final for sure. Find the inverse of the function and prove it's an inverse. So, inverses, you got to switch the x and y to get started. All right, you switch the x and y around. So what does that look like? Well, I'm just going to put an x on the left and put a y on the right. And then I solve for y again. So I will subtract 7. So it's x minus 7 equals negative 4y. And I divide everything by a negative 4. And then I can just rewrite it with a y on the left. So it'd be negative 1/4 x plus 7/4. So that's your inverse, okay? And I'm going to get rid of some of that work. To prove it's an inverse, you got to plug them into each other. Okay, so remember we want f of g of x to equal x, and then g of f of x to equal x. And I'll just do that one way so you can kind of see how it works. Okay, so that's my inverse. I want to plug this into the x there. So it looked like this, negative 4 times negative 1/4 x plus 7/4 plus 7. So distribute. The 1/4 would cancel. I just have an x there, and then that would turn into a negative 7 going into this one, plus 7. So those cancel. So then that would be f of g of x equal x. And that's it. Okay, but you have to do it both ways. So I'd have to do it the other way here as well. I'm just going to save some time and not do it though. All right, given the function, perform the operation. So h of g of 3. So first you got to find g of 3, which is 3 squared minus 9. It looks like that's going to give us a 0. So then that takes the place here. It's h of 0. So then h of 0 equals 2 times 0 plus 1. That is just going to give a 1. Okay? And then we do g plus f minus h. So that means we're just kind of putting all the functions together. So g is this, f is this, and h, since that's a subtraction sign, you have to distribute it through there. You change the signs of everything there. Then you just add like terms. So x squared, I got an x minus 2x, so that's a negative x. And I got a negative 9, that's at 8, so negative 1, and another negative 1 is negative 2. That's that. And last one is just f minus g. So I would take x plus 8, and I'm subtracting x squared minus 9. So distribute x plus 8 minus x squared plus 9. Just rearrange stuff then. Plus 17. Okay? Almost there. I think we're going to run out of time before the bell rings here. So I'll just kind of do one of these here. So simplify the stuff on the inside here if you can. All right? So 343 and 27, those reduce. All right, so that's a 7, I think. So that gives me 7, a 12b to the 9th over c squared. Oh, that gives me a 49. My bad. No, it doesn't. 343 divided by 27. Let's check it out. It doesn't simplify. So that stays as a 343. Okay. Oh, but, so we can do it a different way rather than simplifying on the inside first. Let's just take the cube root of the top and the bottom. That's the way that we should do this one. Because we can split it up like that. Otherwise, we're going to end up rationalizing, which we don't like to do that. Which we might have to a little bit here. So the top, you're looking for 3 of a number. We get 7 out of the 343, and then we divide these by 3, and that works out 9. So a to the 4th would be cubed. Okay, because that 9 divided by 3 is a cube. On the bottom, cube root of 27, that's a 3, and then we're left with the cube root of c squared, which we are going to have to rationalize that. Okay, so we have to take it times another c, or cube root of c rather, in order to rationalize it. So it's a 4th, b to the 3rd, cube root of c, all over 3c, because that would complete my radical. Okay? I will make another video later on to work through the remainder of these. So hopefully this helps for the first part. Good luck.